Hello, good morning friends. Myself, Devalas Mistry. I am assistant professor in Mechanical Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center which is situated in Navsari. Today we are going a presentation on arc welding. Arc welding. Arc welding is widely used method of joining the metal parts. Here the source of heat is an electric arc. Arc welding is a group of welding process wherein heating is produced with an electric arc, mostly without the application of pressure and with or without the use of filler metal, depending upon the base plate thickness. Various arc welding processes are first one is carbon arc welding, flux sealed metal arc welding, TIG welding, MIG welding, submerged arc welding, electrosag welding, electro gas welding, and plasma arc welding. An arc welding the welding is which the electric arc is produced to give heat for the purpose of joining a two surfaces is called electric arc welding. The joining by fusion or two or more pieces of metal together by using the heat produced from an electric arc. So in a figure of arc welding process, in arc welding process use of electrode, workpiece, returnable lead cable, welding lead cable, power sources AC or DC supply. The arc welding principle is in arc welding is generated between the positive pole of DC direct current called an anode and negative pole of DC called cathode. When these two poles are brought together and separate for a small distance, 1.5 to 3 mm, such that the current continues to flow through a path of ionized particle called plasma, an electric arc is formed. Since the resistance of this ionized gas column is high, so more ions will flow from anode to the cathode. Heat is generated and in the ions strike the cathode. The first type of TIG welding process. Gas tungsten arc welding. Gas tungsten arc welding is an arc welding process that uses of a non-consumable tungsten electrode and an electric gas for an arc shield. It is also known as gas tungsten arc welding. In the arc welding process, welding heat is produced from an electric arc established between the tungsten electrode and the jaw. A shielded gas, argon, helium, nitrogen, is used to avoid the atmospheric contamination of the molten weld pool. Filler metal, if required, is fed separately. Argon is normally preferred over helium because it requires a lower arc voltage, easier arc standing, and provide a smooth arc action. It is uneconomical and heaviest. Helium can withstand the higher arc voltage, so it is used where higher heat input is required. Sometimes active gas carbon dioxide is also used as is more economical. It requires slightly higher current. It is normally used with the only DC with positive electrode, whereas both argon and helium can be used with the AC as well as DC welding power source. Equipment used in a TIG welding: gas supplier, cylinder, electric power source AC or DC, electrode holder, torch or gun, connection cable, hose for gas supply, tungsten electrode, coolant, and filler rod. These are the use of equipment used in TIG welding. The working principle of TIG welding is an arc kick established between the end of a tungsten electrode and the parent metal at the joining line. A constant current welding power supply is used to produce energy which is conducted across the arc through a column of high ionized gas and the metal vapors known as plasma. Argon and helium are the most commonly used of shielded gas. So in a figure, this is the tungsten inert gas welding. So in a figure, direction of weld, filler rod, electric arc, copper saw, GTA, W head, power shielded gas, contact tube, tungsten electrode, weld base and shielded gas. This process use of non-consumable tungsten electrode which is mounted in a special electrode holder. This holder is also designed for furnish a flow of inert gas around the electrode and around the arc. Welding operation is done by strike an arc between the workpiece and the tungsten electrode is an atmosphere of inert gas. The arc is struck either by touching the electrode with a scrap metal tungsten piece or use of higher frequency unit after striking the arc. It is allowed to imping of the job and the molten weld pool is created. The weld torch and the filler metal are generally kept inclined at the angle of 70 to 80 degree and 10 to 20 degree respectively with the flat workpiece. Filler metal, if required, should be added by dipping the filler rod in the weld pool. When doing so, the tungsten electrode should be taken a little away from the weld pool. However, the heated and the filler rod as well as electrode should be within the inert gas seal. Both DC and AC power supply can be used. The advantages of this TIG welding is the first one is no flux is used, so no danger of flux entrapment, clear visibility of the arc, so better control. It can be welded in all position. High quality weld of thin material as thin as 0.125 mm. Heat affected zone is very less. Unlike metal can be welded to each other like mild steel to stainless steel, brass or copper. Disadvantages of TIG welding: tungsten if transfer can be contaminate the weld pool. Filler rod and if by chances come out the inert gas shield can be cause weld metal contamination. Equipment costs are higher than the flux sealed metal arc welding. Electrode is non-consumable, so separate filler rod is needed, so there is a decrease in a welding speed. Application: welding of carbon steel, stainless steel, nickel, aluminum, magnesium, brass, copper, bronze, titanium, etc. Welding of sheet metal and thinner section. Used in aircraft, rocket motor chambers, transistor cases and instrument industry. These are the application of the TIG welding. Next is metal inert gas welding. In this welding process, welding heat is produced from an electric arc established between the continuous fed metal electrode and the job. Argon, helium, carbon dioxide or a gas mixture shield on the arc and the molten metal from atmospheric contamination. Metal inert gas welding, also known as MAG and GMAW. It is a semi-automatic or automatic arc welding process in which a continuous and consumable wire electrode and shielded gas are fed through a welding gun. An electric arc from between the consumable wire electrode and the workpiece metal which hit the workpiece metal causing them is melt and joint. The equipment and setup is first one is cylinder, pressure regulator, pressure gauge, flexible hose, welding gun, power source, welding return lead and clamp and earth connection. MIG welding process. In a MIG welding is a gas shielded metal arc welding process using the heat of the electric arc between a continuously fed consumable electrode wire and the material to be welded. A wire of copper coated mild steel is fed continuously from the rail through a gun which a melting rate up to a 5 mm per minute. Current through the wire range from 100 to 400 ampere depending upon the diameter of the wire. CO2 is principally used apart from argon or helium mixture as a shielded gas. The welding machine is a DC constant volume machine. The typically set of our process is the consumable electrode is in form of wire reel which is fed in a constant rate to the feed roller. The welding torch is connected to the gas supply cylinder which provide a necessary inert gas. The electrode and the workpiece are connected to the welding power supply. The power supply are the generally of the constant voltage type only. The current from the weld machine is changed by the changing the rate of feeding of the electric wire. Normally, DC are the machine are use of the metal arc welding electrode positive. The increasing of the metal depending rate and also provide a stable arc and smooth electrode meter transfer. For semi-atomic process, the arc length is maintained constant by using the principle of the self-adjusted arc self-control arc. So in a figure, the consumable wire is used the solid wire electrode, current conductor, shielded gas. The wire guide and the contact tube, solidified weld metal, nozzle, shielded gas are base metal, molten weld metal. So in a figure, the advantages of a metal arc welding is does not require the higher degree of operator skill. Continuous weld are higher speed and its all position with deeper penetration is possible. Thick and thin both type of workpiece can be welded effectively. The process can be easily machining. Since no flux is used, so more visibility, netness, cleanness, practice-free weld. The disadvantages of this welding equipment is more complex and more costly. The metallurgical and mechanical properties of the joint may be affected due to the high cooling rate. It is difficult to weld in a small corner. Process variable are more. The application is it is suitable for welding variety of ferrous and non-ferrous metal. Metal fabrication industry, shipbuilding, automobile, pressure vessel industry, etc. Weld tool steel and dies. These are the metal arc welding. Next is comparison between the TIG and MIG. First one start with the MIG. Semi-automatic or automatic process, a consumable bare wire electrode fed continuously into the weld pulled through the torch by spool. An inert gas argon has the flux action and the create the protective shield around the weld pool. The field and flow are separated by the operator does not produce like use of sheet metal. And the TIG is utilize the non-consumable tungsten electrode. An electric arc is formed between the non-consumable electrode and the metal weakened weld. The inert gas as argon created protective gas shield. A filler metal is added manually and no slag is produced. Then the difference between first discuss TIG. In TIG welding, use of permanent or non-consumable tungsten electrode. In a MIG use of consumable continuously coiled electrode of same chemical composition and the material being welded. Second one in TIG welding electrodes serve a purpose of producing the arc only, filler rod is added separately. In MIG welding electrodes serve both of the purpose of producing the arc as well as of the filler metal. In TIG is not as a fast MIG because of this separate filler rod is added. In MIG is fast as compared to the TIG because the electrode and filler metal is same which is in form of wire. In TIG welding require a skill operator and MIG no so much skill required for the operator. In TIG, if the filler metal is added, operators both hands are engaged, so work must be held in a position with clamp or fixer. In MIG welding, the wire electrode and gases come from the same run and thus can be made easily automatic. In In TIG welding, usually use of a direct current straight polarity, but case of welding thin sheet, direct current reverse polarity is used. In MIG uses both type of polarity, generally direct current reverse polarity used. In TIG welding torch is water cooled, and in MIG generally no water cooled is necessary. In TIG, tungsten, if by chance comes in contact with the molten metal, cause a contamination of the weld pool. In MIG, no such problem is there is a MIG no tungsten electrode. In TIG welding is not used often for welding plates thicker than 6 mm. In MIG, it is best suitable for thick more than 6 mm jobs. In TIG, penetration is not so much deeper as in MIG. In MIG, deeper penetration can be obtained as compared to TIG. In this video, we are covered up the three main topics. First one is TIG, second one is MIG, and third one is comparison between the TIG and MIG. It is the most IMP question asked in GTU exam. Thank you.